Hey, it's Caroline. Today I'm going to be talking about what you guys need to know for the upcoming strain sensing lab. This lab is going to be split over 2 weeks. So for the first week, you need to come in with your circuit done, your Arduino and processing codes written up, and your pre-lab questions done. So the pre-lab is exercises 1 through 5, and by reading through the lab material, you'll have all the equations you need to know in order to do that pre-lab. Then you'll need to wire up the circuit in figure 8 with the potentiometer. So that's the circuit that I have shown here. And you'll be testing that circuit, you'll be demonstrating that circuit in lab. So the processing and Arduino codes that go along with that are very similar to the codes that you used for the op-amp lab last week, but you will need to edit the processing code so that you make sure it's plotting your values over a large enough period of time. You'll need about 30 seconds to show up, so if the screen that you have is too small, you'll need to edit that and definitely make sure it's larger. In total, you're going to need 2 different Arduino codes and 2 different processing codes. You'll need a slow version of Arduino and processing and a faster version. That's what you're going to use ultimately for your strain gauge sensing, but you do need to have that done by the first week. When you demonstrate your potentiometer circuit, like the one I have shown here, you'll use the slower code. So something important to keep in mind with this circuit is that you have a very large gain in your amplifier circuit. So that's because with the strain gauges, the difference that in voltage that you'll see is very, very small, so we need to amplify it very large. However, when we're using the potentiometer and we can easily get a larger change in voltage, that means we're going to have to be very, very delicate with moving the potentiometer so that you don't get too much difference. So because you have a really large gain, you're going to have to just make very small adjustments to the potentiometer in order to be able to balance your Wheatstone bridge. All right, so for the second week, and you might do this the first week if you have time, but you'll actually swap in the strain gauge into your Wheatstone bridge in order to measure the strain. So you can see here, this is where the strain gauge will ultimately get swapped into your Wheatstone bridge. And you'll leave the potentiometer in where it is because you'll need to make sure that the resistance here matches very exactly what the resistance of the strain gauge is. And that's very important. If it's not exactly right, the circuit's not going to work. So it does need to be very precise. So what you'll actually need the second week, you'll need to take measurements of the strain gauge that you're using. Try to get all of the measurements done in 1 week. Otherwise, you'll probably have to redo them the second week because you might not have the exact same strain gauge. So you'll be building a quarter bridge. So that just means that you'll have one strain gauge replacing one of the resistors in the bridge. So then you'll have to take 2 different sets of measurements. The first one is the static strain measurements. So you'll use the slower codes for that one. And then you'll want to answer the questions. There should be about 3 questions related to those measurements. And you'll turn those along with appropriate graphs showing your measurements in the next week. Same thing goes with the dynamics testing. So you'll want to do dynamic testing, and for both of them, make sure to get several sets of good data. And then you'll have to answer the appropriate questions and turn those in along with plots showing your data the next week. In the diagram right here, you can just see all of the different components of the circuit kind of laid out so that you can see where they are. Like over here, demonstrating that this is the voltage divider, and so that's what goes into the voltage follower. And then altogether, the output of the voltage divider and the voltage follower gives you your virtual ground, which is going to go into the differential amplifier circuit. And so the Wheatstone bridge goes in between the non-inverting and inverting inputs to the differential amplifier circuit. And then what comes out of that, which has the large gain, is your actual output. You can see that wired up here. It's really important for this one to kind of spread out your circuit as much as you can. It'll make it a lot easier to work with, like the Wheatstone bridge over here. All right, thanks for watching, guys.